Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 6, Lesson 3, Session 1, Notes, Exploring Rotation. Okay, so learning targets. I can rotate figures on the coordinate plane. I can use coordinate notation to describe a rotation and identify the center and angle of rotation. And I can use repeated reasoning to explain why a rotated figure preserves size and shape of the original figure. So let's take a look at this. Okay, so I'm just going to skip over this. This is a in-class discussion, just what do you notice, what do you wonder, and this is a rotation, and that's the center's not moving, and that is the point of rotation. But let's move on. So the Garcias got a new couch and love seat. They want to rotate the love seat 90 degrees clockwise around the center of the coffee table. Well, for starters, let's talk about this word right here, clockwise. Okay, so if you think about a clock, okay, clockwise is this direction. Okay. Counterclockwise is the opposite direction. So this one's clockwise, so we want to go this way. So what are we they want to rotate the love seat. So if I just get a rectangle here, that would represent the love seat like so. Okay. And I put a dot here. Excuse me. And I'm going to rotate these. So remember the dot is right here. So when I rotate this, it doesn't allow me to rotate in place per se. But if the dot is right there and I rotate this, is that right? It is. So if we rotate this 90 degrees about the center of the coffee table, which is right there, where would we be? Well, to be honest with you, we'd be partway through the wall. Okay. So anyway, but the love seat would be placed roughly there. So we're rotating this direction clockwise. So we're just trying to get comfortable with terminology. Clockwise goes this way, 90 degrees. By the way, if I had this set up as a coordinate system like this, okay, 90 degrees would be this distance here from the x-axis to the y-axis is 90 degrees clockwise. So a rotation turns a figure about a fixed point called the center of rotation. What fixed point is the love seat being rotated around? Well, they told us to do it from the center of this coffee table. The Garcias rotate the love seat 90 degrees clockwise. There's the center of rotation, and now they're showing a better description that is 90 degrees, and we're going in this direction. They did, however, make it closer. So when I showed you where it rotated, it really would have been back here further, but they scooted it up so it's not in the wall. Then it says, where would the love seat be located if it were rotated 90 degrees counterclockwise? Well, let's take a look. So if I get another rectangle to represent our pre-image right there, and I draw a dot center of rotation, and I rotate both of these together, like so. Now I'm rotating counterclockwise, which is against the clock this way. And I would have to move this dot up to here. Okay. So that is where the love seat would end up if we rotated it counterclockwise. It'd be sitting on top of the couch. Okay. So here's where it would be rotated clockwise. They aren't showing the counterclockwise rotation. What remains the same about the love seat after the rotation? Well, size. Still a love seat. It's not a couch. It's not a chair. And shape. Okay. Size and shape do not change. What changed was the location and the orientation. It was facing this way, now it's facing this way. So the orientation also changes on a rotation. The size and shape of the love seat has not changed. This is an example of rigid motion. Transformation because the shape and size of the love seat does not change. The Garcia's got a new couch. Okay, now we're saying, oh, this is just a repeat. I don't need to read all that. It's the same. Let's explore more. Where would the love seat be placed if it were rotated 360 degrees clockwise about the center of rotation? So what they're asking us to do here is move this love seat, which is right here, about the center of this room, which is the center of the coffee table, I mean. And then, so I'm doing the same thing again. I'm going to make a group so that this and this are one thing, and I can rotate them. So if I rotate this 300, there's 90, here's 90 degrees, here's 180, here's 270, there's 360. Where would it be located if we rotated it clockwise about the center of rotation? It'd be back where it started. Okay, it would be in the same exact location. 360-degree rotation puts us back to where we were. My classmate concludes that if the love seat was rotated 270 degrees clockwise, counterclockwise, it will be the same location as 90 degrees clockwise. Is your classmate correct? So basically what they're saying here is, if I take that rectangle right here, and I'm going to make two of them, I'll make one black, I'll make one red. Okay. And then I'm going to place, let me move, I'm going to make two pieces here. So I'm going to put a dot in the center. Okay, right here. And I'm going to connect these two. Okay. So it says if you rotate counterclockwise 270, so there's 90, and this would be here actually. And then rotate it again 90, which is a total of 180 degrees, it would be there. And then rotate it another 90, which is now 270 degrees. It would put the couch, love seat, I mean, right there. So now if I put this here and draw a red dot right here, and then I combine these two, this one they say to rotate 90 degrees clockwise. So that would be this way. And that would end up right here. Okay. So it landed right on top of the other one. As you can see, they're both in the same location. Is your classmate correct? They said it'd be in the same location. And yes, a 270-degree counterclockwise rotation results in the same location as a 90-degree clockwise rotation. Okay. And that brings us to the end of session 1. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 3, Lesson 14, Session 2, solving problems using the 4 operations with negative numbers. The The earliest pinball machines did not come equipped with flippers to prevent the ball from falling through the center hole. Instead, players could tilt the device in the hopes of gaining a more favorable outcome. Okay. But then the new machines, when they have these flippers, if you try to lift the machine, it'll actually default the game, and it was actually called a tilt. So anyway, here's a problem. Elena sells replacement parts for pinball machines. One customer buys a new part that costs $44.50, okay, and returns two parts that cost $26.30 and $21.40. Is the cost of the new part more or less than the return? So really all we're doing here is adding and subtracting. So it's going to be $44.50 is positive. That's what they're buying. Excuse me. And then we're going to return the two parts. So is the cost of the new part more or less than the return? So how about we could do this separately? How about we just combine the $26.30 part and the $21.40 part and add them, because these are getting returned and the sum is going to be the return amount, and we get $47.70. I'm going to call that a positive and this a negative, because when you spend money, that's a debit, and when you return things, you get money back. That's a credit, so that's going to be a positive. So the cost of the new part, which was $44.50, is less than the return. Okay. And now it says how much more or less. I didn't answer that part. My apologies. How much more or less? Well, then we get $47.70, subtract $44.50, and I get 0, 2, 3, and it's a difference of $3.20. Okay, that's a $3.20 credit. Oops, so it wouldn't be negative, it's positive. Spending's negative, returning's a positive. Okay, this is a duplicate, so I don't need that. You can approximate the answer by rounding each value to the nearest $5 or the nearest $1. So actual amount, $44.50, round to the nearest $5, that'd be $45. Round to the nearest $1, that would be $45. Okay, so we're now doing approximating. Actual amount, negative $26.30, rounded to the nearest $5 would round down. You'd cut off $1.30 to make it a negative 25. Rounding to the nearest dollar, you would just get rid of the 30 cents and end up with $26 negative. Actual amount, negative $21.40. Rounded to the nearest $5. This is closer to 20 than it is 25, so it's negative 20. Rounded to the nearest dollar, you just get rid of the dollar amount if it's less than 50 cents. If it was more, you would round up to 22. You can write and evaluate an expression to find the exact value. So 44.50 minus 26.30 minus 21.40. So I did it separately. Let me go back and look at how we did it here. I separated the purchase from the return and then subtracted their differences. But in this situation, they're taking 44.50 minus 26.30 minus 21.40 and then making it addition. 44.50 plus a negative 26.30 plus a negative 21.40. Okay. So I'm not really liking the way they did this right here, because if we're going to talk about order of operations, let me just explain this again. Okay, if we're going to do it this way, we have addition, we have addition. Whenever we have just addition or subtraction, you are supposed to work left to right. So in all actuality, we should have done this first, gotten a new value here, and then added negative 21 to it. You would get the same answer, but we're still not following the order of operations if we do the last two first. Okay. Adriana is rock climbing. She started at an elevation of negative 36.5 meters relative to sea level. So she's in a valley or something like that. Okay. And we'll finish at an elevation of 25.75 meters. Her climb is now 80% complete. Estimate her current elevation, then find the actual elevation. Okay. So what's going on here is she has a starting elevation, okay, started at, and then she has a finished elevation here, but she's only 80% complete. So she's not at this elevation, she's below it. So we need to find the distance between these two. So if I take 25.75, okay, and add a negative 36.5 meters, okay, so we're combining these two. Actually, it's not plus a negative, it's going to be minus. Okay, so whenever we're finding the difference between top and bottom, actually, let me start this over and let's write it in order. So we're starting at an elevation. Actually, I would like to go higher first. So 25.75 is the top. So this is the finish. Okay, so somewhere down the way, and here's sea level, is the, let's see, start. So starting at negative 36, this is negative 36.5, and this is positive 25.34. I'm just going to draw a picture here. Okay, this is where we start. This is where we're going to finish. This is sea level. Okay. I want to know how far apart these are. You subtract. And so minus a negative 36.5 is going to turn into plus 36.5. However, I can't add. I need to convert these into fractions. So 25, 3/4 is 0.75. That one's easy. We don't need to use a long division to find that. 3/4 is 75, or 3/4 is 75 cents. You could think of it that way. All right, so we have 25.75 plus 36.5. 0. I'm going to have the same number of decimal places, and then I'm just going to add them. 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. 5 plus 6 is 11. Plus 1 is 12. Carry the 1. 2 plus 3 is 5. Plus 1 is 6. 2 decimal places. So the distance is 62.25 meters from here all the way to there. Okay, that's 62. So this is 36, and then 25 more gets us to 62.25 meters of elevation, but she's only at 80%. So now I'm going to take that 62.25, forgot my 2, 62.25, and 80% is equal to 0.80, or just simply 0.8 as a decimal. So we move the decimal 2 places to the left to turn a percent into a decimal. And so I'm going to multiply by 0.8. And actually, rather than writing it next to it, I should write underneath it 0.8. So 8 times 5 is 40. We carry the 4. 8 times 2 is 16, plus 4 is 20. 8 times 2 is 16, plus 2 is 18. Carry the 1. 6 times 8 is 48, plus 1 is 49. 3 decimal places gets us to 49.8 meters above sea level. Or not above sea level, above the starting point, my fault. Okay. So it says, find her actual elevation, show your work. She is at 49.8 meters away from the starting point. So this is still not the right answer. That's the total distance. So now I have to, so that's not my answer. Let me get that off that solution line. So my answer is not 49.8 meters. 49.8 meters is 80%. We need to know where she is. What elevation is she at if she goes 49 from that negative 36? Okay. So from here to here is 36.5. So if I subtract 49.8 minus 36.5, I'm going to get 3, 3, 1. So she's actually 13.3 meters above sea level if she's gone 80%, which is 49.8 meters. So her actual elevation is 13.3 meters above sea level. Okay, that one was a pretty challenging problem. Number 8, Glenn, Andre, and Ramon share the cost of renting a vacation cottage. Okay, the total cost, is $960. Glenn pays 30% of the total cost. Andre is going to pay 45.45 of the total cost, and Ramon is going to pay the remainder. Okay, how much does Ramon pay? So what I need to do here is find out what 30% of 960 is. So 900, whoops, what's that doing? 960, okay, times 30%. And remember, 30% is 0.3, right? Move it 2 decimal places, it's 0.3. So I'm going to multiply this by 0.3, and that will be 30% of 960. 0, 6 times 3 is 18, carry the 1, 9 times 3 is 27, plus 1 is 28. I have a decimal place. So Glenn, I'll write these over here. Glenn, his payment was $288. Okay, 30% of 960. Andre pays 0.45 of the total. Well, that's 45% written as a decimal already. So we're going to take 960 times 0.45 and multiply. 5 times 0 is 0. 6 times 5 is 30. Carry the 3. 9 times 5 is 45. Plus 3 is 48. Put a place marker. 4 times 0 is 0. 4 times 6 is 24. And 9 times 4 is 36. Plus 2 is 38. Add. 8 and 4 is 12. Carry the 1. 8 and 4 is 12. And 1 is 13. Carry the 1. 3 and 1 is 4. We have 2 decimal places. Okay. So Andre's paying 45%, which is more. Maybe he's got a bigger bedroom or something. He's paying $432. Okay. So Ramon's paying the rest. So all we have to do is add these two up. $720. We take the 960 total. Glenn paid $288. Andre paid $432. That's a sum of $720. And Andre is going to pay. I'm sorry, not Andre. Ramon is going to pay the difference of this. 6 minus 2 is 4. 9 minus 7 is 2. Ramon is going to pay $240. Okay. So Ramon's getting off cheapest. He's paying $48 less than Glenn, and Andre's paying the most. Okay, now closing exit ticket, simplify. This is an order of operations, so I'm going to write the word GEMDAS up here. And what do we have? We have grouping. So we have grouping. We have multiplication. We have subtraction. And we have division. So we're going to do the grouping first. And when I say grouping, I mean what's in the parentheses in the numerator. So I'm going to write 0.5, leave the parentheses, but then I'm going to off to the side, I'm going to take negative 77.8 and subtract 11.0 or 11. Okay. That's 8, and that's 8. So this is negative 88.8 all over negative 4. Okay, so the grouping is done, no exponents. Now we're going to multiply. And the subtraction's gone because we did the grouping. So now it's just multiply and divide. So we're going to multiply here. And multiplying by 0.5 means to divide by 2. So I'm just going to do that quickly. So that's going to be, this means half, right? 0.5 is 1/2. What's 1/2 of 88.8? Well, it's negative 44.4. Okay, so that's this times this, and then divided by -4. Okay, and now that's done, and now we do the division. Well, a negative divided by a negative is positive. 4 goes into 4 once. 4 goes into 4 once. Decimal place. 4 goes into 4 once. So this simplifies to 11.1. And that brings us to the end of session 2. Thanks for watching, and have a great day.